Alright, today I'm going to make a video about mechanisms and reaction mechanisms. So mechanisms are like pretty much going to go through from year 12 and year 13, and if you go to uni and you require something that relates to chemistry, you're going to be doing mechanisms. So it's important to know the basics of mechanisms. So a reaction mechanism shows the formation of new bonds in a sequence that they're created. So there's different parts of a mechanism. One of them is curly arrows. Curly arrows are used to show the movement of a pair of electrons. So this is useful to show the formation of a new bond. So alright, so let's just draw an example. This is just for curly arrows. It could be anything, but I'm just gonna pick this example. So let's do a nucleophilic addition reaction. Haven't really explained what nucleophiles are, but I'll probably do another video on that. So CH3 here, positive carbocation, CH3. So the curly arrow is very important that you always do a curly arrow from your electron to, so it's always from the negative to positive, always goes from negative to positive. So always go from here. It's never the other way around, always from your electron to your more positive, your electrophile. Nucleophile to electrophile, that's what it always goes. And after that, just show here, OH. Shows it here. I'll just draw up this off here. Alright, so national molecule there, so it'll be 1, 2, 3. This is 2-methyl propan 2-ol. There you go. But it's the idea of the curly. That's the most important thing here is that the curly arrow, which I'm trying to show, always goes from negative to positive, and it has to be a curl. If the curl isn't there, you aren't going to get the mark. And yeah, that's it really. Okay, so it shows the movement of electrons. So the curly arrows show the movement of electrons from nucleophiles to electrophiles, or electrophilic groups. Always from negative to positive, not the other way around. That's how it's meant to be done. And then let me just draw this one here. We've also got bond breaking. So curly arrows can also show the breaking of a bond. So if I had like an example here, probably put an example down here. All right, let's have this molecule here. Shall I do it the other way around? Actually, it probably makes more sense to do it here. It's weird to see. Alright, so if I wanted to show the bond breaking, I'm going to show the electrons in this bond are going to this positive here, the bromine, showing the breaking of a bond. Go here, go. Probably shouldn't be that big actually. There you go. and then CH3. If I'm mistaken, you don't actually need to write Br here, but I always write it down just in case to show that, because it's not really part of it anymore. But as the whole point is to show that, look, the curly arrow here can also be shown to break the bond as well as bond forming. It's always showing the movement of electrons. That's what it is, the curly arrow. And it always has to be curly, and it's always going from the electrons to the more positive atom. Yeah. And finally, I've probably done a video about this already, but it got free radicals. And free radicals are molecules or atoms with an unpaired electron. And for this reason, free radicals are very reactive for this reason. And an unpaired electron is shown using a dot, as shown there. So you always put a little dot there to show that it's unpaired. The reason why they come unpaired, I made a video about it, the initiation, the propagation, the termination steps. But obviously it comes a free radical because of the initiation step, because of UV light. But if you still don't know about free radicals, you can just watch the video about that. I made that a couple of videos ago, titled free radicals. But whenever you see this, you got a free radical. Atoms always, free radicals always are very reactive because they want to be paired. They don't like being isolated like this. They always want to be paired and always going to react because they need to go and react with another chloride, becomes, in this case, Cl2, because it can't just be unpaired like this. And yeah, that's it really.